Hi guys, let's solve today's Leetcode problem, which is problem number 1914, cyclic rotating a grid. It's a medium problem. Let's read this out. You're given an m cross n matrix grid where m and n are both even in integers and an integer k. Okay, the matrix is composed of several layers, which is shown in the below image, where each color is its own layer. Okay, a cyclic rotation of a matrix is done by cyclically rotating each layer in the matrix. So cyclically rotate layer once. Each layer in the layer will take the place of adjacent elements in the counterclockwise direction. An example of the rotation is shown below. Okay. Return the matrix applying k cyclic rotations to it. The blue color boxes, these are these are one layer. Okay, then this another box, if you see, this is another layer. So this layer by layer we have to rotate the elements adjacent to each other in counterclockwise direction. Okay, so this is the counterclockwise direction, basically anti-clockwise. So in this example, if you see, so this was the matrix first, and when we rotated, okay, so this was before rotation, and after doing one rotation, so here this you see 2 3 4, this element shifted to one place like this. Now you see this one 5 6 7 8 9, so this shifted to one position above. Okay, this, then you see this one 12 11 10, this shifted rightwards toward one position. And if you then see this one, so this has shifted downwards one position. So all together, all of these elements, they have shifted one position from their place. Okay, so this is after one rotation. So similarly, we have to return the matrix by applying k cyclic rotation to each of these layers. Okay, so this was about the first layer. If you see, same would be for the, okay, so this is how the cyclic rotation is happening. Basically, each position is moving to its adjacent in the counterclockwise direction. Okay, so yeah, and now constraints, if we see, so n and m can be up to 50 only, and both are even integers. K can be up to 10 to the power 9, so we have to handle the modulo case as well, so that we don't keep on just rotating, because this will give us TLE, so we have to consider the doing modulo. What are we going to cover as part of this problem? Basically the brute force approach, where we will be doing this layer by layer, each layer, and we will be rotating each layer k times. Okay, and this will we will do in place. Then there is optimal solution that we are going to do, that would be optimal with respect to time, and the same thing we will do layer by layer only, but instead of rotating k times we will use some additional space to avoid doing the same thing k times. Rather we will do that in O of one time only. Okay, this k time would be reduced in the optimal approach. Okay, now let's understand few things before we start. So if you see here, so this was a 4 cross 4 matrix, and number of layers, if you see here, so how many number of layers are there? So this is one layer, this is another layer, right? That can be max 2 layers. Okay, now if you see this one 2 cross 2 matrix, so there is only one layer. In this one, if you see 6 cross 6, so here there is only one layer, two layer, and three layer, right? So what we observe, now let's see this one also 6 cross 4. So one layer, two layer. So if we observe carefully, so number of layers would be nothing but whatever is the minimum of m and n by 2. Okay. So that would be our number of layers, a minimum of m comma n by 2. Okay. So that would be our number of layers in a matrix. Okay, now what would be the total number of layers in each layer? So now if you see in this grids, if let's say I call this one as my top pointer, this one as my bottom pointer, okay, and this one as my left pointer, and this one as my right pointer. Okay, so total number of elements in each layer. Okay, so if you see, we have to consider the first row. If we just, let's calculate the total number of elements in each layer. Okay, so now we will calculate in the first layer. So if in this one, if you see, so what it is from 0 1 and 3, right? So what we can do, number of this would be nothing but right minus left plus 1, right? Because this is the index, right? But total number of elements here are 4. Okay, so we need to do this additional plus 1. And the same thing will be for bottom one also, right? Last row also, same things. So we can do this into 2. Okay, plus now we have to do this first column and the last column. And this is also, if you see above, it is going from 0 till 3. So we can subtract this value. So we will get what? Bottom minus top. We need to do additional plus 1 because these are the indexes. And same thing for the first column and the last column. So we need to do into 2. Now if you see, while doing this, we added, right? But these corners, bottom, the the corners in the matrix, these will be shared, right? The one that we have calculated. So this will be calculated here also and then here also. So this will be overall, this particular cell will be calculated twice, and same will happen for all the corners. So for that reason, we need to subtract additional 4. Okay. So this will be for one layer, the first layer. And if we just calculate also, right? So 2 into left minus, sorry, right minus left, that is 3 plus 1, 4, plus this is again 4 into 2 minus 4. So this is 8 into 8, 16 minus 4, that is equal to 12. And if you see this first layer count, number of elements, there are 12 only. So that is how we are going to do. Now if you see in the next layer, so I added these pointers, if you see top, bottom, left and right, these pointers. Now when I go to this layer, what this pointer will also change, right? So in this particular layer, the left value has decreased by 1. So here left is 1. Here top is also 1. Here right has also reduced to a value, that is 2. And the bottom, if you see, that is also reduced to one value, 2. So all of this value, top, left, right and bottom, all these 4 pointer values has been reduced. Now if you apply the same formula to find, number of elements in second layer, so it would be 2 into right, what is right? So 2 minus 1 plus 1, and same thing bottom minus top, so it is again 2 minus 1 plus 1 into 2 minus 4, right? This is our formula. So if we do so it is 4 plus 4 minus 4 is equal to 4. And if you see, there are 4, you know a cell here, 4 elements in this second layer. So that is how we are going to calculate number of elements in each layer. And if we just simplify this equation, right, so it would be 2 times right minus left, and we will take out this 2 into 1, right? So it would be plus 2, and from here also, here we had this 2 multiplication, right? So 2 into 1, it will also give us plus 2. So plus 2 from here, plus 2 from here, and minus 4 from here, that will equal to 0. So we can simply write it as 2 into altogether bottom minus top. Okay, so this is the number of elements in each uh, layer. Okay, so these are a few things that we are going to need in our overall problem solving. These pointers, how are we moving it every in each layer, and number of elements in each layer. Now let's solve this layer by layer. Okay, so as I pointed, our left pointer will be here, right pointer will be here, here we are top pointer, and then same bottom. Okay, so these are the places where our these pointers will be pointing. Now, what we can do, we can keep on doing this layer by layer. So we knew that in first layer we were having some values for this. When we came to next layer, we reduced all of these values. So for, I mean, left and top, we increase the value by plus 1, and right and bottom we decrease the value by minus 1. We can do these reductions or increasing in this value until this top is less than bottom and right left is less than right. So till then we can shrink on our layers and we will keep on getting our layers, right? So after this we know number of elements in each layer. We will be knowing that number of elements. Okay, now other thing we need to know is how many, since here this is our layer 1. Now this layer we are going to move k times. Okay, so k rotations we need to do in each layer, and as I mentioned that k can be up to 10 to the power 9, but this actually need not to be done those many rotations. So how many rotations we really need to do? So we have this number of elements, right? So we will do mod of this value. Only that many rotations is needed because let's say in a very simple example, if this is an array, if we rotate this by 3 times, we know we will get back the same array. Okay, if this is 1 2 3, after 3 rotation again I will get 1 2 3 only. So any rotation that is equal to or greater than that value will give us the some same repetitive value that we would have got earlier, right? So for that reason we do mod of k. Okay, so our rotations that we are going to do would be k mod number of elements. Okay, now after this for every rotation we will be iterating and then doing. Okay, so now we know k rotations we need to do in each layer. Now every time if you see, this was our uh, matrix before rotation, and after rotation we see that this basically thing moved here. Okay, and this one, if you see, this moved above like this one moved like this, and this one finally moved here. Okay, so uh, I mean, if you might have solved, the spiral matrix problem, this is something similar to that. Okay, I mean, there we do rotation and we keep on doing, I mean, like this in the matrix. But here, instead of doing that, you see, we are doing placing these positions one position backside. Okay, say we started with this one, which is nothing but from left to, I mean, left to right. If we go, so this entire block, we are moving one position shift, right? So if we just shift it, after shifting, we know that this will be gone, right? We won't be having track of this value. So what we can do, we can store this. This is our left and this is our top, right? So we can store this in our some temp variable. Okay. Now this will be safely stored for us. Now we moved this particular thing one step here. Okay, we are good because for moving this one here, I know what is the next value, so I can move. So while placing, what we need to place here, we have to think in that manner. Okay, so place 2 in this position, we know next is 3, so 3 we will place. To what do we need to place in this position? So here next is 4, so we will place here 4. So likewise we will be able to do. So we have to fill this position. What do we need to fill with the next position? What is next? 5. So we filled 5 here. For here, what is next? So next is 6. So we filled 6 here. Here 7. So we filled 7. Here 8. So we filled 8. Next 9. So we filled 9. Okay. Now after that we are done with this one, this one. Now we will start with this one. What is here? 10. So we will fill 10 here. What is here? 11. We'll fill 11 here. What is here? 12. We fill 12 here. Now this is also done. Now for this one, what is here? 13. We fill 13. 14. We fill 14. 15. We fill 15. 16. We fill 16. Now we know that here our metrics would have changed, right? Because you see here 2 is there, 3 is there, 4 is there. But in other situations, whenever we were filling the next positions, we knew that next values were not hampered, right? So we were able to use the previous values. But for this one, this is already hampered. This value was changed to 2, this corner value, top left value. So that is why we need to store this in a temp variable, which we stored. Now we can place this here. So this will how we will get this 1. So yeah, that is how we are going to do for one layer, and then same logic we will apply for every layer. Okay, and layer transformation I already told. So these pointers are there, they will keep on shrinking. So at every time we will get our next layer and then we will keep on doing this. Okay, so yeah, this is all for this. Now let's write code for this. Okay, ns grid dot size and ms grid of 0 dot size. Okay, need some pointers. Okay, so int top equal to 0, left equal to 0, right equal to m minus 1, and bottom equal to n minus 1. Okay, now while top is less than bottom and left is less than right, so this is the shrinking condition till when we will get our layers. Now we will calculate number of elements, okay, in each layer. So I already told you the formula for this that we calculated above. Bottom minus top plus 2 into right minus left. Okay, so this is the formula, and then we will calculate number of rotations we need to do, so which will be nothing but k mod total, that is number of element over number of element. Okay, now while we have to do this rotation. Okay, these many times rotation times, as I explained, we need to store the temporary variable the grid top left value, as we are shifting one position, so this value will be lost after doing this rotation, as we are doing in place, so we need to store that. Now what we will do, so we will go from left to right. Okay, our loop will go from j equal to left, because column is shifting, right, j less than right and j plus plus. Now grid of top j would be nothing but grid of top j plus 1. Okay, so as mentioned, in this grid position what we will be filling whatever is here, so that is how we will be able to shift this. So that we are doing grid of top j, we are placing the position item in the j plus 1. So top to right, this is done. Okay, now sorry, left to right is done. Now so in this manner, uh, we are moving the positions one by one position upwards. Okay, so while going to top to bottom, from whatever is there in the next, we need to place current position. So again our loop will go from I equal to top, I less than bottom, I plus plus grid of I and right equal to, because we are doing this for the last column, so yeah, that's why right grid of, and here I is changing, right, so I plus 1 and right. So this top to bottom is done. So again we have this, we need to go like this in this direction, but position element positions we need to do like this, right, we need to make the rotation in this anti-clockwise manner. So we will be moving in this direction, and whatever is here, I mean what we need to place here is what is here, right. So that is how we will be able to do this anti-clockwise movement, right. So we need to place elements whatever is here like this. Okay, so same we will do while moving from j is equal to right and j greater than left, j minus minus, and grid of bottom, as we are doing this for bottom row, and j is equal to grid of bottom j minus 1. Okay, as for placing this position, we need to use whatever is there in the backside. That is how we will be able to do anti-clockwise movement. So yeah, now for I equal to bottom till I less than up is nothing but our top. Okay, and I minus minus. So I should be greater than top. Okay, here grid of. So again we came to this place, and we need to we need to do this movement, right? So now if we start from here, whatever is there in the back, we will need to place here. Okay, so this is I minus 1, right? So grid of I of this left. Basically, we are doing this for this starting column, that is left column, would be nothing but grid of I minus 1 and left. Okay, so that is how we are able to move all this. But so after rotation, one rotation, we know that this top left position would have moved here, right? So after this anti-clockwise rotation, this is the next position of this top left corner. That is one value of top. So we will place this grid of top plus 1 and left to the temporary variable that we have stored in the value. So that is k rotations, and we will do this rotations k times, and after this the k rotation for this. So for this layer, the k rotation is done. Now we need to move to next layer. So for moving next layer, we need to shrink our boundaries, right? So same thing we will do, we will shrink it. It will be top plus plus, left plus plus, and bottom minus minus, and right minus minus. Okay, so yeah, that is done. And since we have done all these things in the in place, so we can return grid at the end. Okay, so yeah, that's all about this approach. Now let's discuss the time complexity. So this is total number of this loop is nothing but it will move for total number of layers, right? Because this that we had the first layer. Okay, and after this first layer we shrink all of this top left bottom, right, to get the next layer. So altogether this will move to a number of layers times, right? And number of layers is nothing but minimum of n comma n by 2. Okay, now this rotation, this is nothing but number of elements, and number of elements we calculated is like this. Okay, and this rotation k can be anything, but total number of rotations that we are going to do is that will be at max these many times. Okay, number of elements. So total of number of rotations we will do is at max number of elements, and number of elements is this value. So we are doing layers into number of elements. Okay, so for each layer we are going to do these many rotations. And if you see number of layers at max when we visit these elements, right, so this will be nothing but we are visiting all the cells of it. So for this layers, moving the layers only, we will be moving m into n, and this number of elements is nothing but min of m comma n by 2. So yeah, this would be the time complexity. And if we discuss the space complexity, it is O of 1 because we are doing this in place. We have not used anything additional. So that was about the brute force approach. And this is the additional k rotations that we are doing. So we will be saving this in the next approach. Now let's discuss the optimal solution for this. So here also we will be doing this layer by layer, but using the additional space to save the k rotation that we do, right? So same thing as done above, we will be having this layer in terms of 4 pointers that we have, and we will be shrinking those layers. But instead of doing k rotations, we will be doing just storing the values in that particular manner and then using it. Okay, now let's understand how normal rotation works. So this, let's say if this is our array, and so if we need to rotate this anti-clockwise, okay, so whatever is here, let's say I have to rotate this by 2 position. So after 2 rotation, this will come somewhere here, right? After 2 rotation, so we know that if we need to place something here, I need to use what was stored here, right? I mean, something sort of reverse. So whatever is here, I need to use what was here. If this is a in form of a single array, right? So we have to think in the same direction. What we will do, this is our layer. Same thing, we will go over and store the values in this uh, layer in a array. Okay, in this array, we would have stored all these elements, all elements in the layer. We need to know the positions of those layers as well. So what we will do, we will have one another array for row for storing row indexes and another array for storing column indexes. Okay, so yeah, for all of these values, we will have the values here and the row index and the column index. Now, when I have this value stored here, now all these values are stored, right? And the same, how we will store? Using the same logic that we have applied above, right? Use moving like left to right, then from top to bottom, then from right to left, and from bottom to up. The same manner, we will store these values. Now, a key thing is after we have stored all these values, right, the same manner, now we need to know the total number of rotations I mean, above we were doing the rotations, but here instead of doing the rotation, we need to know how many rotations actually needed. We need to know that, right? Because that modulo we need to do. So rotations that will be having, that will be actually k mod the total number of elements. Okay. Now after we have stored this, now we have to use this value that is stored. So from this matrix we got this, and from this we need to again get back our that layer. Okay, so whatever was there in this layer, in this particular layer, from these values we need to get it back. So how will we get that back? So this layer are stored in terms of single array, if you see. So here we have stored the row index and column index, right? So row index and column index, it tells nothing but what is the position of this value. So if I say in simple terms, I know the position that is for this grid. Let's say these are the positions. Now I have to fill something here. Okay. What would be this something? This something, let's say I would have to do 2 times rotation. So whatever value was here, that will come to here, right? Whatever was over here, that will come here, right? So this has stored the indexes, and this index I have to fill the value. And what value I will fill? The value that is in 2 positions plus. Okay. So that is the logic that we are going to apply to restore this matrix back from the values. So what we are doing, these are the positions, row and column index that we have stored, and we are going to use these positions to fill using the values that we have stored. And what we will fill? that will be stored in this plus k position, right? So let's say I am, so this is stored in terms of this index, right? So we need to iterate over this only. So let's say I am at this index I, and I need to fill this row and index in this particular grid. Let's say I need to fill this one, and to fill this one, currently I am at this index I. What value will be filled here will be nothing but we need to do plus of this rotation, right? So how many number of rotation we need to do? We will do plus of that times. Now let's say I am at this place and I have to do 5 rotations. So 5 rotations will go out of bound, right? So we know that after 5 rotation, it is nothing but it comes to starting, right? Starting place. So for that reason, we need to do modulo. Okay. So after doing the modulo with what number of elements that we have? Okay. I mean, this is the index. This is the index of the values that we will be using. Okay, so this was the core difference from what we were doing above and here. Above we were going over each layer by layer, and then doing each rotation one by one. Here instead we have used another piece of arrays, and there we are using that as a extra space, and from there we are calculating it back. So we don't really need to do this rotation k times, rather we can just get the actual position of these elements after k movements. Okay, so yeah, that's the core difference. Now let's write the code for this. So I have written the same thing as above. We have this n and m stored, then this top left and bottom right pointers, and this loop to go over each layers, and this total number of elements that we have calculated. Now additionally, we need to know for each layer, this we need to store the in rows. I'll just write it as R, columns, and the values. Okay, so the row will store the row index, column will store the column index, and value will store the value. Okay, now same thing we will do. We will move all this move in all this grid, and then we will store these values. Okay, so I'll just quickly write that out. So now we will be moving from left to right, and while moving left to right we will store the values for this row, column, and then values. Okay, so what will be the row will be when we move left to right. So row is constant, and that is the top value. Okay, so r dot pushback top. Okay, and j is changing here. Okay, so we have changed the value j, so that is our column. So here we'll push back j. Okay, and value is the value at each places. Just we need to push back those values. So grid of top and j. So yeah, this is the value that we need to push. Now from top to bottom. So this is top to bottom we go. We will store these values. So again in a row, we know that row is changing now. So row dot pushback I, then column dot pushback. So this is the last column, right? So we need to push right. That is our last column. And same thing in value, we will push back this grid of I and right. Okay. Same thing we will do for from right to left. So when we go in this direction, right to left. So here again j is changing and I is constant. So what is I? I is nothing but the bottom value. So in row we will push back I, and column we will push back j, which is changing, sorry, in row we push the bottom value, okay, because this is the last row for which we are doing. In column we push back the j which is changing, and then in value we will push back this bottom grid of bottom and j, okay. So this is done for left to right. Now from bottom to up we need to fill. So bottom to top in row, row is again changing, that is our value I. So in row we will push back I. In column, column is not changing, which is the first column, that is left. So we will push back left. Now in values we need to push back the grid value for this. So grid of I and left, okay. So yeah, after this we whatever the values that have been stored in this boundary, right, in this layer, we would have stored that in our values array and those positions into row and column uh, array, okay. Now we have stored these in these array, right? From this grid we got these arrays. Now from this array we need to store back our grid values after the rotation for that layer. So number of rotations we said we will do k, but we need to do the modulo also. So we have stored the total number of elements in this layer, right? So we will use another variable kk to store the mod of this value, okay, number of elements, okay, because we will do that those many rotations only. Now we will iterate on this array that we have formed. So and I is equal to 0, I less than n, I plus plus. Now we will calculate the index as I discussed above, that is I plus kk mod total, okay. Now this is the index that we have calculated where we need to store the values, okay. So this value array has the value and we have the grid position, and what is the value that need to be stored in this particular grid position. So that is in this value array, whatever the value is in the rotation. After k rotation we know this is the value and these are the position, let's say. So in these positions this value will be stored after, let's say this was the k after k rotation. So we need to know this, so that is how we will know the index, and same thing we will use. So in grid of this R of I will give us the row value, C of I will give us the column value. Here we need to store the value of this index that we have found, okay. So we have formed our grid back for that layer after k rotations, and then we will shrink our layer by doing this thing what we did above, and then at the end we can return the grid. So yeah, that was all about this approach. So time complexity here is O of m into n, because at max if you see for every element in this grid we are going to rotate, we are going only one time, okay, nothing more than that, just one time doing some operation and getting back the values, okay. And space complexity, for every layer we are using this space, and what is the layer that value it can have. So it can have m plus n values in average, I would say, because first layer will have, let's say, 2 into m plus n, second layer will have lesser number of values. So each layer will have these values. So at max we can, I mean on an average we can say that this is the space that it is going to take in each level. So yeah, that's about space and time complexity for this approach. I hope you like this video. Thank you for watching. Stay tuned for next videos.